Hello again, you sick, twisted weather freaks, and welcome to another weather video from weatherrisk.com. It's Friday evening at 6 p.m. and we have more winter weather to talk about. And this particular episode is just going to be devoted to what I think could or might happen with regard to the next event, January 2nd, 3rd, or 4th. I'm your host, as usual, meteorologist DT from weatherrisk.com, and the first reaction I'm probably going to get from many of you will be, well, Dave, since we're still dealing with this event for tomorrow, why are you talking about the next one? Well, because that's what I do. Everybody else can be talking about the current event. I'm looking ahead. That's my job. That's what I get paid the big bucks for. And that's where my skill lies. So let's get into this one and see what the potential is. Now, I thought about doing a write-up and just posting on the Facebook page, but there's so much to say, and I love the sound of my voice so much that I just had to do another recording. And really, there's just a lot to talk about with this particular system and why I think it's got some potential. So let's get right to it. In my first slide here, we'll be talking, I want to make a couple of points clear. First of all, with regard to January 2nd, 3rd, and 4th, 2013, most of the data shows it's going to be very cold and dry across the mid-Atlantic states with no threat of any kind. And the cold front will be way down along the Gulf Coast. That's what all the models are showing. That's what everybody's forecast has. And there's no possible reason to think anything else is happening, right? Wrong. Because the job as a meteorologist is to think outside of the box, not simply regurgitate the latest piece of crap from the latest model. So that's what we're supposed to be doing here. Let's take a look at the 12Z, or regular operational GFS, and of course this is going to be here from today here, December 28th. So let's take a look-see. All right, this first event, this first map here is the GFS now, and this is for going to be here. I guess this would be for this valid for December 31st. So this is today's run, and I call up a good color here so we can use this one. I guess we can use this color here. Lots of colors to choose from. And this here's the feature we're talking about, this upper low. All right, now all the models have this, the big huge feature right here. And here's our ridge. You can see the ridge right in this area there. There's our cold air coming southward, beginning to come southward. And here's our Caribbean ridge in here. All right, let's go to the next slide. Now, this is as of 120 hours. Now, what's happening here is that the models now see the ridge here a little bit. You see the ridge? We can see this, right? There's the ridge. So the flow is like this, as you can see. And any sort of moisture or storm trying to develop in here would be carried along the Gulf Coast. Now, the feature is looking a little weaker, but we can still see it coming out. And you see this one here? This is acting as a kicker. See what it's doing? It's dislodging this feature, so it has to come east. All right. But by the time we get to January 3rd, what's happened? The upper low, which was over here in the southwest states, is now completely gone. It's completely disappeared from the map, and the GFS has absolutely no sign that it was here. So it was here. Now where is it? I don't know. Now what's happening here, this is a classic case of the GFS killing the system with the northern branch. And we can see the northern branch coming in here and going boom and crushing this sucker and knocking it flat, and there's no storm and nothing in the southeast along the Gulf Coast states. So that's what the GFS is doing. By the way, you don't have to do the sound effects if you don't want to, but it makes the weather a lot more interesting if you do the sound effects. All right, so that's what the GFS is doing here. Now, as a result, it's doing that because the model is showing nothing here. We end up getting, let me change the map here, nothing here. This little low, which we can see right here, goes off the coast. And there's a little bit of snow and ice in North Carolina, nothing in Virginia at all. Here's a gigantic Arctic high, another Arctic high. Now this is cold air mass. We do not have to worry about temperatures or boundary level temperatures or mixing with rain or anything like that. This is a darn cold air mass. This blue line here, this is the rain snow line. It's way down by Charlotte, North Carolina. It is cold. So this whole scenario, let's go over this for a second, is based upon key assumption here that the GFS is going to crush that big upper low, the one that's in the southwest states, the one that's over here. It's going to crush this thing. So as a result, it leads to a very weak system here. But suppose this is a much stronger system, then this feature is going to be much stronger as well. You follow me? Weak system here, strong system there. weak system there, strong, weaker system here. It's just that simple. It's really not more complicated than that. Now let's take a look. This is the GFS, the total precip for the period January 2nd, 3rd, and 4th. Look what we can see a lot of precip here, but again, all right along here. See it? Just along the edge like this. That's the half-inch precip. So it's got snow in North Carolina, a little bit in Hampton Roads, but nothing in most of Virginia. All of it's down in here. But this is based upon a weak southwest low. That's what this is all based on. Okay? If that southwest low is stronger, this whole system and the precip is going to be a lot further north and going to be a lot heavier. And this is the ensemble mean. Again, this is all 22 members of the GFS averaged out, January 2nd, 3rd, or 4th. Now, the temperatures clearly support snow or ice over portions of Tennessee, North Carolina, central and southern Virginia. Not a lot, a half inch to an inch, but if you're a snow-starved weather nut, this would be okay. But again, most of the precip, as we can see, is way down in this area, as you can see. So, that's the GFS ensemble. Now, if we look at the actual individual members, again, you'll see that most of the members here, these are all the GFS ensembles. And you take these all together, and that's how you get this image. But we break them apart. Only one model has any sort of significant snow into central Virginia here. And that would be this one right here. See it? So that's the only one that does. All the others have the precip south. But that's all based upon the big low in the southwest getting crushed as it comes east. Now, there are some examples of this, where the models screw this up. And the best example of this is the only snow we had in Virginia, North Carolina, last year during the warm winter. Remember the February 19th, 20th snowstorm we had? Now, it was about 4 inches in Richmond and about 6 or 7 out in Lynchburg and Roanoke. Let's take a look at that. This was the map. We can see it. And again, like I said, this is as of February 19th. Let's take a look at the date. See if I can enlarge this a little bit here. If I can enlarge this a little bit. Yes, I can. And then we can see the date. I guess not. And but anyway, we can see the date here. February 19. There it is. And here's the low. Now it's down here in Alabama. And look what's going to happen here. In the next slide, it's going to slide off the coast. It goes from Alabama to this. And that ends up giving Richmond and North Carolina, Western Virginia a pretty good snowstorm. So that's what the models are doing. That's what actually happened. This is the actual precip. Look at that. Those are pretty good precipitation amounts. Okay? Now, how did this happen? Again, look at this. This is the jet stream map from February 17. See that? Look at this, a southwest low. See the northwest flow coming south in Pennsylvania? So again, the system cannot go north. No, it can't do that. It has to do this. It has to. And look at the flow here again. Look at the flow. Call this up. This direction, this direction, this direction. Okay? That's important. Now here's the system, the next slide. We can see it. And then finally, here, the system is right in here. You can see. And that's produced the low here, which went to here. Okay. That's what the models are showing. That's what actually happened, excuse me. These are actual facts. Now, let's take a look at the model. The model last year, this is the European from February 12th. Now, look at this low. From February 12th, valid for the 19th. What does the European do? Even the European takes the system out to sea. This is a miss for Richmond and Central Virginia and Roanoke, Lynchburg, Southwest, Maryland. This is a complete miss. It does nothing. But that's what the model had, and it was wrong. It was too far to the south and east. Why? Because it had nothing over here. It was too weak over here. So the model screwed it up. Again, weak here. Let me change this. Weak here and weak there. It's that simple. Okay. Now, this is the actual GFS ensemble here. Now, this is real time again. We're doing real time now. So this is the GFS ensemble valid for January 2nd. Here's the big upper low, as you can see. Got it? Right in here. Got it? There's the big upper low. There's our Arctic jet. I see right there. Look how far south it's in Pennsylvania again. And here's our southern jet. And again, look at the ridge. Look at the flow. It's like this. It's like this. It's not west to east. It's not doing that. Okay. Next slide. 24 hours later, what happens to the upper low? There? It's gone. Oh, there's a little bit of a system left over Texas, but this thing is completely wiped out. Why? Because the GFS is overdoing this polar jet this Arctic jet coming southward, and it's crushing the system. It's crushing the system. It's crushing it, and then it does this. So that's what's wrong. This is not correct. The GFS is weakening the system too fast. And then finally, this is January 4th. This is a joke, right? Where'd the upper low go? Come on, this is silly. This is silly. Come on, folks. Give me a break. All right, let's take a look at the European. The European's doing the same thing, though, folks. The European's doing the same thing. So we can see the cold air. Look at the now. This, remember the black line here on the European. Let me call this up. This is the rain snow line. Whoops. This is the rain snow line right here. See that's down North Carolina. Now here's the upper low. Comes the polar jet, the Arctic jet. So that's fine. Now this is valid for January 2nd. This is January 3rd. What's going on? Well, this looks very weak. This is going boom. It's blasting it southward. See, that's crushing it. Okay. We have a little bit of precip along here, but that's about it. A little bit of precip that way, and then finally, there's nothing there. This is January 4th. Nothing. A little low, way out here, going out. That's nothing. That's what the European is showing. The European ain't going anywhere either with this, folks. So what are you talking about, DT? Well, let's take a look. This is the European ensemble mean. There's the upper low, as you can see right here. Got it? Make sure this is right. Right in here. Now look at the flow. West, southwest, east, northeast. See that? There's your south. There's your ridge here. So the moisture coming from the system has to be affected in this direction. That's the point. This is the European ensemble now for the January 2nd into the 3rd. Now this European has this stronger system. This is significantly stronger here on the European than the GFS. And it also sees the Caribbean ridge. So again, the flow, look at the flow here. The flow is going this direction, this direction, this direction. So that means the moisture on the Gulf Coast gets pushed into the Carolinas and Tennessee and central and southern Virginia. That's what this is telling me. At least that's what I think it's telling me. But even here, the European, this is now for January 4th. The European may be weakening the southwest low too fast. It's got a better organized system, but it's still maybe weakening it too much. And look at this Arctic jet coming southward. Boom! Right in Pennsylvania. Wow. That's just very cold air. And there's your southeast ridge. Well, it's a Caribbean ridge. It's not a southeast ridge. So, all right. Now, this is the European ensemble. From the folks at EarthSat. Thank you very much. And this is from this morning. Now look what it's doing here. This is an average of the European ensemble. And these are the surface maps. A little bit of light precip in here. See that? A little bit of light precip. All the heavy precip's down here. This is this afternoon. Uh-oh. Heavier precip getting into Richmond and Norfolk. That's all snow, folks. That's minus 40 to 50. That's all snow. So, and this actually even could be an ice storm for some places in the deep south. I don't know. So this is the potential. The key is going to be the system coming out of the southwest. So let's talk in the summary here. First, in this potential for January 2nd, 3rd, or 4th, I could be completely wrong. I'm going against most of the data. Now, there will be plenty of cold air over North Carolina, Tennessee, Virginia, Maryland. Now, the models are guessing, all right, that the a big upper low of the southwest by California. Now this is going to be a stronger feature. The stronger it is, the more rain over the deep south and the more snow or ice over North Carolina, Tennessee, and Virginia. The northern portion of the deep south could even see ice storm out of this, no doubt about it. Okay, and the ridge over the Bahamas, that's the key. The flow is not going to be west to east. It's going to be west southwest to east northeast. So that's why I think some of the moisture will get affected that far north. We're not looking at a big surface low. There's no phasing going on here. This is just overrunning, the warm air overrunning the Arctic air at the surface. Now the northern jet is too strong, and you can see, remember I was plunging southward from western Canada all the way into Illinois and Pennsylvania and Kentucky and Ohio. That means the northern edge of the precipitation shield will only get to so far north, then it will stop. It may never reach Richmond for all I know. It may reach Washington, D.C. But wherever that northern edge is, that's going to be the boundary. There'll be no phasing and no big storm coming up the coast based upon the model that I'm seeing right now. But this is the best potential so far that I've seen in a while for portions of Tennessee, North Carolina, Virginia, southern Kentucky, southern West Virginia. We'll see what happens. I could be wrong, but we'll see. This is meteorologist DT. I'll talk to you soon.